Look at regression lines, how you can calculate it using your Casio CG-50 calculators, and some exam style questions that use it. So what is a regression line? A regression line is an equation in the form of y equals ax plus b, which is very similar to y equals mx plus c, right? It's essentially in the same form. And using this equation, you can use it to find out your y value based on your x value when you have bivariate data. So given your x and y values, you can use it to calculate your y value at a certain point. So essentially, if you know these values and you know one x value, but you want to find out what this value is going to be, you can use the regression line to find out what that's going to be. So essentially, for a regression line, you need to use your GDC calculator to calculate the A, and you need to calculate the B values. So let's take a look at how you would do that using an exam style question. This shows us that the number of daily visitors to the famous Bandy Beach in Sydney, where the daily temperature on those days was recorded for 8 days in February, right? So it's the temperature and the number of visitors depending on the temperature. The table below shows the data and has been ordered in ascending order. That's very useful because it's going to make our lives a whole lot easier because we won't have to order it. So ascending, it's a key part, by temperature. The number of visitors to Bondi Beach varies linearly with the temperature, so it has like a relationship between the two. First of all, we're going to find Pearson's coefficient, so this one is going to mean RP, and we need to find the equation of the regression line in the form of y equals ax plus b. And then we're going to use this regression line to estimate, because remember, whatever value of y you get using this regression line, it's always going to be an estimate, the number of visitors during a day when the temperature is 26 degrees Celsius. So yeah, let's get on with it then. First of all, Pearson's value. How do we calculate RP for question I? We're going to need to input these values into our GDC calculator. You're going to enter your statistics tab by pressing number 2, and you're going to use this to move into the correct field. And let's clear the previous information that we had inputted into it. And under list 1, that's going to be our x values, conveniently labeled for us over here. So let's put 20, sorry about that. 20, 21, not sure why this is 20, 21, okay, I'll go a bit more slowly, 22, 23, 24, 25, 27, and 28. So we've currently inputted our x values, now we're going to put in our y values. Y values have 405, 448, 481, 527. Maybe my keyboard's a bit sticky. 527, 565, 601. You want to be real careful when you're inputting this to make not a mistake. 688, otherwise it's going to ruin your whole question. So make sure you double check. And 729. You should have the same number of x and y values. And now that we've done that, we can calculate Pearson's coefficient. We're going to press, so usually you would be out here. You're going to press calculate, press regression, you can press x and ax plus b. And then r is 0.999. So now we can go into the page. And we now know it's going to be 0.999659. Remember in IB we always use 3 significant figures. So that's going to roughly equal 0.99. Well, this value, this is the 3rd significant figure, right? It's going to round up because of the 6. It's going to become a 0. This value is going to round up again. That's going to become a 0. That's going to round up again. That's going to become a 0. So it's going to become 1. Our Pearson value is 1 to 3 significant figures. So you can say RP is equal to 1 to 3 significant figures. Now the equation of the regression line, right? That we calculate using this equation over here, y equals ax plus b. To calculate that, we're going to need to know our a and b values, which is going to be fixed for the whole thing. And because we just calculated it, we can just recycle the a and b values that are provided right over here. So that means our a value is 40.342 and our b value is going to be negative 402.63. And again, it's going to be to 3 significant figures. So if I write it here, it's going to be 40.3 for the a value. For the v value, it's going to be negative 403 to 3 significant figures. We can input that into our equation to get y equals 40.3 x minus 403. Now remember, this was the a value. This was the b value. The equation of the regression line, therefore, is y equals 40.3x minus 403. Now, the final part is to use this regression line to estimate the number of visitors, right? The x value is the temperature, and they told us the temperature is 26 degrees Celsius. Now, this value doesn't have to be within the values provided. So we're just going to sub in 26, although it's not part of the data set that was originally there. So y, which is the value we're looking for, the number of visitors, is going to be 40.3 brackets our temperature, 26. Remember, this means we're multiplying 40.3 by 26 minus the b value, which is 403. And at this point, it's just going to be simple maths, which gives us an answer of 644.8, and to 3 significant figures, that's going to be 645 people. So the estimate of the number of visitors is going to be 645 visitors. Now the regression line, we need to know 2 key terms that are very, very important. It's called interpolation and extrapolation. When you're interpolated, when your data is interpolated, it means the x value is within. This is the key part. It's within the range of the data set. For example, the question we just did right now, our x value was 26 degrees Celsius. When it's within the data set, it doesn't mean we need to have 26 as part of the data. But as you can see, the data ranges from 20 all the way to a maximum of 28. As 26 is part of this, it is within the data set. So it is going to mean that it is interpolated within the data set. The x value is part of the range of the data set. Extrapolation means the x value is beyond the range of the data set. Now, why is this important? When your data is interpolated, it means your data is going to be reliable, meaning the y value you get using the regression line is going to be reliable if the x value you inputted is within the data set. However, if it extrapolates, if the x value is beyond, it's going to mean it is unreliable. as there is going to be, it's kind of common sense really. If the x value you input is beyond the data set that was used to make the regression line, there is no guarantee that the relationship continues beyond the observed values. Hence, it's likely to be unreliable. It's not saying it will always be unreliable, but it's likely to be unreliable. So for example, in the context of this question, if we inputted a temperature of 32 degrees Celsius, because it's beyond the range of the data set, we don't know if this relationship between x and y values continues all the way up to 32. Hence, we can still use it to calculate, but it's going to be a rough approximate. There's no guarantee. All right, let's move on to the next question. Gippsland in Victoria, Australia is an important milk-producing farmland area. So now we're talking about the production of milk. Some people argue that because of transportation costs, the cost of milk increases with the distance of markets from Gippsland. The table below shows the price in 8 markets. So distance from Gippsland, which is the production site, and the cost of milk. So distance, this is further away, 1,300 kilometers away. And the price is 2.64, 2.69. When you're the closest, so 2,500 kilometers away, remember this is the context, 2.19. So let's find out if there's a relationship. First of all, finding the Pearson's product momentum correlation coefficient, which is RP. How do we calculate that? We need to input this data into our calculator. Let's press exit, and let's go back to list 1, and let's clear the data set. Likewise for list 2, just clear the data set, and let's input our x values. Remember to do so in chronological order, so 12.45, 4.25, 13.46, 9.73, 2.55, 8.65, 8.22, and I think it was 2.96, yes. Sorry, 2.96. Why do I keep typing 8 in? 8.22 and then 2.96, and then let's go down to the y values. 2.64, 2.31, 2.69, 2.52, 2.19, 2.55, 2.40, and 2.37. To calculate the regression line, you would have had to have pressed calculate, regression in bold, and x, ax plus b, and you're going to get an r value of 0.940. Now with that value, let's write that down, 0.9406. And remember, we're always in 3 significance figures, so that's going to mean in 3 sig 0.941, rounded, right? So we can write that down, RP equals 0.941. We can comment on the result obtained for R. So we can say, because the value is very close to 1, it's going to be a very strong positive correlation. The equation of the regression line for this data is in the form y equals mx plus c. Find the value of m and comment on its meaning. Now previously I said it's in the form of y equals, I said ax plus, yes. That's the same as mx plus c, but the point of me saying this is because in your calculator it's going to be labeled a and b, as you can see here, A and B. So it's just easier if you remember it as AX plus B rather than MX plus B. MX plus C, but the thing itself is the same. We're going to find the value of M and comment on its meaning. Let's calculate the regression line then. Well, the A value was 0.0384. 0.0384. And the B value was 2.159. 2.1591. If we put that to 3 sig figs, A is going to be 0.038. Remember, the first 0 doesn't count as a significant figure, so we need 384. What's the next digit? 9. So that would have rounded up to a 5 actually, because this is a 9. And remember, the first 0 doesn't count as a significant figure. It's from the second onward. It's from the first non-zero digit that you start counting significant figures. So this 4 is the third significant figure. Because the next one is a 9, the 4 is going to round up to a 5. And the B value is 2.159 to 3 significant figures. Because it's in the form of AX plus B, and they're asking for the value of M, the value of M is going to be equal to the value of A, which is 0.0385. So you can say M equals 0.0385 to 3 significant figures. And they want us to comment on its meaning. What does this value mean? The M is the gradient of the slope, right? So we can say it is the gradient of the slope. Now, when they ask for its meaning in IB, we need to put it into the context of the question. That's why they give us all this information. So make sure you relate back to the question. So this, we didn't refer back to the question yet. Meaning, now we're going to relate the cost of milk increases by 0.04. We're going to round it to the closest unit of currency, 0.04 cents. Remember, let's put in the currency of AUD per additional 100-kilometer distance. Now, how did I reach this conclusion? Well, it told us the distance from Gippsland is in per 100 kilometer in the question right here, in hundreds of kilometer. So as it increases by this amount, the gradient is 0.385. The slope is 0.385. That's the rate of change. Because the distance is at 100 kilometers, the rate of change of the price is 0.385. And because this isn't a coin or something that's used in currency, usually currency is to 2 decimal points, right? We round it to the closest cents. And then if not, now let's do the second part. So this was for I. So for I, find the value of C and interpret its meaning. The value of C, we already calculated that. That's the value of B, because V and C are interchangeable here, right? So that was 2.159, or to 3 significant figures, that would be 2.159. So C equals 2.159, and interpret its meaning if appropriate. What is C in the equation y equals mx plus c? C is the y-intercept, right? So it is the y-intercept. And if appropriate, is it appropriate or not? Well, C is the y-intercept, so it's going to be the point the line crosses the y-axis. And therefore, it's going to be important as it shows the price of milk when distance is at 0. So when you're within Gippsland itself, when the distance is 0, within the country, within the town where the factory of milk is located. So, and it's important as it shows the price of milk within Gippsland, so distance equals 0, is 2.16 AUD per liter. This is how you need to answer this. Interpret its meaning, comment on its meaning question, relate it back to the question at hand. That is pretty much everything you need to know. And let me just leave you with two important things. When the prediction using regression lines not accurate when there are two key scenarios. Number one, predicting x values by inputting y values is not reliable. What do I mean by that? In the context of this question, we are asked to calculate, not in this question, in the first question actually, to calculate the number of visitors to the beach based on the temperature, which was the x value, right? If we were instead given the number of visitors, say we had a number of visitors being 904, that would mean our x value is provided, and we're trying to find the y value of the temperature at which it corresponds. Now that is not reliable. So predicting x values by inputting y values is not reliable. Your question might ask you to calculate it, but then it might ask you why it's not valid. So you need to say that it's not valid because calculating x values using y values is not reliable. And number two, if the data is not linear. If the data set is not linear, it might fall down. So this also kind of corresponds to anomalies. It shouldn't really have anomalies in order for it to be accurate.